cut your video if you're not interested in appearing. So for the webinar agenda, first of all, we have a brief introduction to the Bio4HUMAN project, which is organizing this webinar today, that will be done by myself. Then we have a presentation about the LCA methodological gaps in the bio-based sector, given by Margarida Vidinha. It's also from WeLoop, which is she's also a partner in the project Calimero that will be presented just after by Eduardo. We have also a presentation from Aligned, so seeing the methodologies from Massimo from Aalborg University, and at the end, the presentation from the LCA for Bio project methodology given by Lucia Garcia, also from Contactica. Of course, we will have questions and answers just after each presentation, but we will have a small period of questions at the end of all the presentations if needed. So a quick introduction to the Bio4HUMAN project. So Bio4HUMAN, full name is identifying bio-based solutions for waste management applicable to the humanitarian sector. It's a Horizon Europe project that has started in January 2024 and lasts until June 2026. We are 10 partners with a multi-actor approach. Inspire is our coordinator, and we have partners in the humanitarian aid, in specific contents in research centers from, for example, Itene and Namplas. We have Universidade de Cantabria, Percivis, IBF, Bio4 Hub, and WeLoop. We are divided in 9 work packages. So what is the Bio4HUMAN from what is the subject of the project? So we are talking about the humanitarian aid, and in crisis we are focusing on people and their well-being. We can easily forget about the aspect of waste generated both by humanitarian aid actors and the recipients of aid. And according to the Global Waste Management Outlook 2024 report published by the UNEP, humanitarian operations produce thousands of tons of solid waste each year. As a result, solid waste can accumulate quickly and in large amounts, posing real challenge for the local population. This crisis in humanitarian settings is growing and in urgency because much of this waste is not biodegradable, thus contribute to soil and water pollution, degradation of local ecosystems, and reducing this waste is not only a matter of environmental protection, but also a matter of the well-being of the population. So to address this challenge, innovative and sustainable initiatives are needed, integrating practices of material reduction, reuse, recycling, into the humanitarian programs that can significantly reduce the ecological footprint of these operations. And for example, using biodegradable or recyclable materials for packaging, as well as promoting effective waste management systems within camps, which are essential measures to be implemented. So that's the main objective, the main focus of the Bio4HUMAN project. So which are our objectives? So we focus on assessing the scope of bio-based innovative technological solutions and bio-based systems having the potential to be applied under the humanitarian context, defining the needs of the humanitarian sector in solid waste management, and also assessing the possible innovative solutions that would be able to be used to fit these needs. And then we conduct the life cycle assessment of these solutions that have been previously identified. And that's why today we are doing this webinar also to identify the different LCA methodologies that we can use to realize these LCAs of the solutions. Then we have also objective perspective regarding the socioeconomic and governance aspects and replication potential, evaluating the socioeconomic and governance aspects of the solutions identified, and also doing a feasibility study on two case studies in 2 African countries, in the Democratic Republic of Congo and also South Sudan. And at the end, we want to develop guidelines for different actors as policymakers, bio-based sector actors, humanitarian aid, and the scientific community. So some of the outputs of the project we have already done, for example, the stakeholder analysis and the humanitarian sector needs assessment. We are working now in the list of the bio-based solutions, the gaps identification report, and all the work package regarding the life cycle assessment and the social and economic aspects. Normally we start at the beginning of December, but we have already start of discuss about it. So that's also a point that I would like to talk with you. We start, for example, the socioeconomic governance aspects related to the social LCA that we want to do for some of the solutions. And in this manner, we developed also one survey for the industrial partners related to the bio-based solutions. So if you have time, if you are interested, please feel free to answer and also share our survey. It will be of a very important point for us to identify the social themes related to these aspects in humanitarian aid. So thank you very much. If you want to connect with us, if you have any questions regarding the Bio4HUMAN, here's the email related to it. And now I will give floor to Margarida Vidinha that will also present the methodological gaps for the bio-based sector.
Hi everyone, I'm Margarida from WeLoop. From WeLoop. Hi everyone, can you hear me? They can't answer, yeah. Hi everyone, can you hear me? Yeah, exactly. Okay. No, it's okay like this. So sorry for this technical problem, but I'm Margarida. As I said, I'm from WeLoop, which is also one of the partners of the Calimero project. And just as a quick introduction, I will present some LCA methodology gaps specific for bio-based sectors, which all of these European projects that will be presented after are focusing on and have as initial challenges. So just a broader perspective into methodological challenges that LCA practitioners face quite regularly. They are based mainly on data gaps. So assessing data that a lot of the times it's confidential, and getting primary data from companies a lot of the times involves high costs. Quick changes in technology means that a lot of the data presented in mainstream databases is outdated. Incomplete coverage of elementary flows in also mainstream databases, and the lack of original data sets, which for certain sectors of the bio-based sectors would be quite relevant. And then just some methodological overall gaps, the different modeling approaches that exist that are a lot of the times based on independent guidelines and leads to a lack of harmonization. Finally, also the current lack of standardized methodology to include social and economic dimensions, as well as circularity and criticality considerations. And then focusing on specific gaps for the bio-based sectors. One that it's quite a hot topic right now, the dynamic biogenic carbon accounting. As I'm sure it will be presented, improvements after methodology after the current different approaches that depends on the standards followed in the studies, which lead to oversimplification of the biogenic carbon cycles, considering these 0, 0 or -1 plus 1, which also currently not includes temporal aspects, which justifies the need of dynamic LCA methodologies. And also something which is quite important for example, wood, which is a big part of the bio-based bioeconomy in general, wood products, woodworking sector, accounting for the carbon storage over 100 years. It's still clearly not defined in current methodologies. Another one, the unavailability of the indirect land use indicators. Currently on the direct land use is accounted, for example, in PEF studies at the European level, due to not the existence of an agreed methodology, which would need to consider certain land shifts outside the system boundaries, geographical distances, which vary the ecosystem types, the land characteristics, and management practices from country to country, the tree species, etc. Also, the lack of harmonized methodologies for biodiversity, ecosystem services, and ecotoxicity assessments, and the need for a more development in the development of characterization factors to account for biodiversity loss, ecosystem service impacts, and also for a lot of the chemicals which are found currently in bio-based materials. Another important aspect is circularity and criticality. So for circularity, how to include multiple cycles and cascading flows, it's still not clearly defined. And a lot of circularity methods which are recognized and used in a more business perspective are not 100% aligned with traditional LCA methodologies and even nomenclatures. For criticality in general for bio-based materials, the definition of which bio-based materials can be considered critical, and how to develop those definitions, and also the development of criticality indicators transported to the bio-based sectors. And finally, low data coverage for finalized bio-based materials. So a lot of the times datasets are available mainly for initial raw materials, and we don't find a lot of finished materials in the mainstream databases when we compare to the complexity of bio-based value chains across all the different sectors that we are all working on. And also the lack of geographical representativeness, as I already mentioned before. And yes, this was just a thank you, a brief introduction, because I'm sure all of these all of these European projects are facing this. And now I think we could move on to the Calimeru, which already has some improvements on these aspects.
Okay, thank you, Margarita. I'm trying to share my screen. But I'm not able to share my screen because I think that someone else is sharing the screen.
Just say I'm trying to stop. Yes, good.
Okay. Can you see now my presentation in full screen mode? Or not? Okay, thank you. So first of all, thank you for inviting me to this Bio4HUMAN webinar. My name is Eduardo Entrena. I am environmental engineer and PhD in life cycle assessment. And today I would like to introduce you with a quick overview about the Calimero project as technical coordinator. So starting from giving some key information about this project, the official title is Industry Case Studies Analysis to Improve Environmental Performance and Sustainability of Bio-based Industrial Processes. About the consortium, the Spanish consultancy Contactica is the leading partner. But in this project participate more than 10 partners that are research institution, university, and industry. And about the time extension, it is expected to last about 3 years, and the date to be finalized is June next year. The main aim of the Calimero project is to pave a way toward the transition to a sustainable European bioeconomy by improving the sustainable performance of a series of industrial processes, mainly focused in 5 target bio-based sectors that are construction, woodworking, textiles, pulp and paper, and biochemical. And to do this, up to 10 different case studies were selected around Europe, such as Spain, France, or Belgium. From this main aim, 6 different secondary objectives emerge. Only to mention some of them, it could be the identification of the main barriers in order to apply life cycle sustainability approaches and the source of impacts from the target bio-based sectors, the development of a MOO framework in order to optimize and improve thus industrial processes, or the provision of feasible solutions that enable us to obtain a better sustainable performance apart from the procedures to monitor them. So giving you a quick overview of the roadmap to be followed, here it is presented all the work packages of the Calimero project. First of all, the work package 1, it is related to carrying out a mapping of the sustainability impacts in terms of methodological gaps and challenges related to the bio-based sectors above mentioned. After this, it's important to do an analysis of the specific case study that have been addressed around different European countries. After this, we try to develop a methodological toolbox in order to go one step further in terms of life cycle sustainability assessments applied to bio-based systems. After this, we are now currently working on the BP4 and BP5. On the one hand, the BP4, it is in relation to the development of a framework that enable us to optimize target bio-based sectors. And the BP5 that is in relation to the improvement on the sustainability performance of our selected case studies. From all of that, it is expected to done a series of guidelines and recommendations to a series of key stakeholders that, along with citizens, they are the target of the BP6, that are the exploitation, dissemination, and communication of results of the Calimero project. And last but not least, it will be the BP7, that is the project management itself. So giving you some key information about each one of these work packages that I already mentioned in relation to the VP1 and the VP2. Here it is summarized some of the main challenges that were identified in relation to the issues of the product environmental footprint method in a bioeconomy context. All these challenges have been divided in three different kinds: conceptual, data, and modeling. Starting from the conceptual ones, on the one hand, the specificities of the bio-based system, apart from other key aspects in relation to the bioeconomy strategies, has been identified to not be well addressed in the best methods. So under this situation, we propose to include new impact categories such as biodiversity impacts or modifying existing ones in order to be adapted to the particularities of the bio-based system. On the other hand, there is one additional conceptual challenge in relation to the difficulty when conducting a life cycle sustainability assessment due to the lower maturity of the social life cycle assessment and life cycle cost. Under this situation, we suggest to include additional socioeconomic indicators in a standard way. Moving on the data challenges, there is a lack of monitoring of the industrial processes in terms of physical variables or greenhouse gas emissions. So to remedy this, it's important to carry out simulation processes of the industrial processes. Lastly, there is a modeling challenge in terms of identify the trade-offs that can be between the three dimensions of the sustainability. So the application of a multi-objective optimization framework, it is of paramount importance in this regard. So moving on to the BP3, here is a summary of the methodology that is trying to be applied. As I said before, it is based on the product environmental footprint method. It is the European Commission standard for conducting life cycle assessment. Here we identify that it is required to improve the life cycle assessment itself based on the paper guide. And moving towards a more standard and holistic way of the life cycle sustainability assessment. So in this regard, we identify that there are partial assessment regarding the environmental domain, that is the life cycle assessment, and also that it is required to be integrate the two additional dimensions of the sustainability, that are the social and economic ones. So moving on to giving you some further explanation in this regard about the methodology. On the figure on the left, it is summarize all the improvement that the Calimero methodology proposed in relation to the PEF toolbox. On the left side, it is explained the three main points that we are trying to address. First, the improvement of the environmental indicators in terms of, for example, to include the time dependency of the greenhouse gas emissions to the carbon footprints, as well as the inclusion of additional indicators such as the ecosystem services inputs. Second, the particularization of the different bio-based industry in order to improve the quality of the results. In this regard, we are trying to propose additional characterization factors in terms of toxicity. And third, the integration of the social and economic dimensions for addressing more holistic sustainability studies. In this regard, we propose some indicators and methodology to be applied, such as the net present value or the rate of return for the life cycle costing, or the job creation potential methodology for the social life cycle assessment. Here it is explained in a quick way the work plan to be done and dissemination of the result of this methodology. The two first steps it is in relation to the deliverables that are expected to be submitted on time. In relation to the third step, we are planning to do a workshop in which we like to explain from the academic partners to the industrial one this methodology. But also in June next year, we are trying to conduct an open public workshop in which this methodology it can be explained to everyone. So please stay tuned for further news in this regard. In relation to the VP4, this is related to the multi-objective optimization frame that basically once we are conducting the life cycle inventory analysis of the different case studies, including the simulation of the industrial processes, the result of the life cycle sustainability assessment, we will be analyzed through this MO framework in order to identify the best solutions in terms of trying to enhance the environmental and social performance while reducing the economic impacts. And lastly, BP5 that is also ongoing. The idea here is to propose a sustainability performance solution. So the idea is to collect all the information from the previous work packages of the projects and trying to not only identify solution with sustainability improvement potential, but also to be applied in order to, or with the final aim of propose a series of recommendations and guidelines for different stakeholders. So in order to finalize with this presentation, here I would like to give you a quick overview about the Calimero project in the form of a take-home message. Basically, this project it is based on the characterization of 9 topics that we consider that are relevant to bioeconomy. In relation also to the life cycle solidity assessment methodology. So in this sense, a series of 3 kinds of methodological gaps were identified that are modeling, conceptual, and data. This milestone has enabled us to open the door to expanding and improving the product environmental footprint methodology. In addition to be adapted to the particularities of the bio-based production and consumption system. With all this information, we are trying to apply an analysis of 10 case studies that are integrated into 5 target bio-based sectors, focusing not only on the sustainability assessment optimization, but also in the simulation of the industrial processes with the final aim of providing a series of recommendations and guidelines to 3 key stakeholders in the bioeconomy that are industry, policymakers, and scientific community, which compile the best tailored solutions toward a sustainable development. So it is all from my side. Thank you very much for your attention.
Thank you. Thank you, Eduardo. Can you hear me? Yes, okay. Thank you very much for your presentation. Very much appreciated. I saw that there are some reports that will be published in December regarding some methodologies. Maybe you could also give a focus on this information. I saw that most of them are public, but there is one that is sensitive. Can you give him sound? I think there's. He can't open the mic to speak. Oh, maybe you can. You can. No, I will cut mine. Maybe it's a problem. Okay, but maybe you can answer in the chat directly. But then we have other questions. I think Diverge also is trying to answer directly in the chat about the Calimero project. What do you mean by time-dependent greenhouse gas emissions? Take into account time storage in the product, take into account the time needed to grow the biomass, both. So Diverge also already said answer to both, basically looking at the difference in time between carbon capture and carbon releases. And then there is also another question regarding the if there are plans to leverage what has been done before related to some of these topics in your European projects, as orienting, for example. And yes, of course, orienting has been the starting point in the literature review. And then I don't know if there are any other questions. Otherwise, we can go directly to the presentation of Massimo from Aalborg University. Massimo, can you try to share your screen, please?
Can you hear me?
Yes.
First of all. Okay.
Welcome, Massimo.
Good, thank you. Just a second. And can you see my screen?
Yes, perfect.
Okay, so thank you all for the invitation to present. I'm Massimo Pizzel. I'm a professor at the Department of Planning, Aalborg University in Denmark. And I'm going to introduce you to the Align project, which is a project funded in the same call as the Calimero project. So we are kind of sister projects. And yeah. Oop, that was the final slide. It's very similar to the first one, sorry. So Align is aligning life cycle assessment methods and bio-based sectors for improved environmental performance. And we have 13 partners across Europe, both academic and industrial. And we have three main objectives. The first is to improve and harmonize and align, of course, LCA methodologies for the assessment of bio-based products. When we want to demonstrate or apply these methodologies, or this framework, in fact, methodological framework that I will present later, to apply this and test this framework on specific case studies in the different sectors covered by the project, which are the same sectors that also the Calimero project covers. So chemicals, woodworking, textiles, pulp and paper, and construction. And then we want to make sure that the relevant stakeholders are informed about all this methodological alignment and harmonization that we do in our project, and that the relevant people get access to our tools and methods and then use them. So what is the Align framework? Basically, the overall idea of a project has always been that we know that there is a lot of methods and tools available in the scientific literature that can be used to make better LCAs for bio-based products and to solve some of the problems that practitioners in the industry organizations, some of the problems that they have when doing the LCA of bio-based products. So we know there are solutions out there, but there is a sort of gap between what is available in the scientific community and what is used in practice in real world situations. And we want to bridge this gap in the project. So our scientific framework is based on the selection of what we think the best available methodologies currently. This includes different approaches to LCA, different methods to do specific calculations and analysis, and specific tools to implement this. The framework is also openly available, so we selected things that can be shared. And then the framework is being actually tested on case studies. So it's not just a theoretical thing, but it's something that we have tested and improved via testing. And then it has to be applicable across the 5 sectors that I mentioned before. How is the framework structure? So it is a series of approaches, methods, and tools. And they cover kind of all the phases on LCA according to what is the ISO standards. So we have, for example, in the inventory phase, we have a method here for making dynamic background systems for prospective LCA. When it comes to goal and scope and inventory, we have methods for identification of market constraints. So how is biomass supply going to respond when you increase demand? And we have methods for time and space dependent carbon accounting, and so on. For impact assessment, we have methods and characterization factors for dynamic assessment of climate change and assessment of biodiversity impacts. And for interpretation, we have methods for uncertainty and sensitivity analysis and methods for socioeconomic assessment. I'm going to go more into detail afterwards if we have time. Otherwise, you will get a lot of information in the slides that you can get after this presentation. So where are our methods? Everything is currently already available because the project is now 2 years, has been going for 2 years. So we have already compiled this framework and made it available in an open repository online that you can see here, and you can get it at this link. When you go there, you will find a series of repositories where specific methods are available, and I'll give an example later. I'll give an example now. So, for example, how did we get there, right? So we know that when you have a bio-based product, you need to have an inventory of carbon flows. You need to keep track of the carbon when it comes from biomass. It is then integrated into a product, and then at the end of life of this product, something happens with that again. It might be re-emitted, for example. But also bio-based products have different lifetimes and end of lives. So this carbon uptake and release happens at different point of time. And the impact depends on this timing. So we know from literature that a dynamic approach allows to take into account these time effects. And we also know that a lot of feedstock that is using bio-based product, wood in particular, comes from different management practices. And the current inventories are not dynamic and not diverse, so we have very few data about this. So the questions that we had here were, what are the dynamics of carbon uptake and emission in bio-based products? How can we make inventories that consider these dynamics accurately? And can this improve the modeling of bio-based products, the LCA modeling? So in this specific case, we took an existing carbon flux model that we knew was open and we could use it. This makes time-dependent carbon accounting for a forest plantation. And there's different characteristics, like you can account for above and below ground carbon. You can parameterize the model and so on. But this model was only limited to 2 species. So what we did in the project was to first take the current interface and improve it so that is easier to use, and make guides for using it, fixing bugs, and then extending the coverage of the model to more species so that you can model any type of wood now, or many in any way, most of the European species, optimize for linking it with existing software, and also validate the model. And these are all improvements that we did in the project based starting from existing knowledge trying to bring it to close again the gap between the knowledge and the scientific model and the practice. And then, yeah, this can be applied in many different cases for woodworking, for construction, for pulp and paper, and for biochemicals. Yeah, this is an example of how the model looks like. So we have the biomass in the forest, we have different inputs and the outputs, and different carbon pools, and then you can simulate that dynamic. And then you can get a life cycle inventory out of that. So where do you find the model and the methods? As I said, there is the like main repository that I was showing before, and under that there are sub-repositories, and one of them is, you can see it, a screenshot here. It's called Methods for Foreground Life Cycle Inventory, Framework for Foreground Life Cycle Inventory of Bio-based Sectors, Dynamic Carbon Accounting. So here, this repository will include a data set with all the biomass times, includes the model itself, a tutorial for using it, and the data used to validate the model. And the validation itself, so a report about how we make sure that the model can model actually close to reality. So all this stuff is already available. We are testing it at the end of the project. So it's kind of beta version. At the end of the project will be a final version, because already now that we are using it in the case studies, we can see some issues that we are fixing, and it will be then revised at the end. So you will have in the end. So now you have a model that works, but has some issues, and then you will have a final version tested on the field at the end of a project, which is in about 1 year. Yeah, here I have an overview of all the methods that we have. I'm not sure how much time I have left, but I'll try to go quickly through that. So we have methods for background modeling. In particular here, we have been making tutorials to make prospective LCA. So to take, for example, the tool that many people are using, the premise model for prospective LCA. So to simulate future conditions of your background system. And we have tried to harmonize it to have both attribution and consequential versions, and tutorials for using that. And then guides for how to choose the scenarios, and recommendation for which scenarios to choose, because you can choose a lot of future scenarios, and then examples on how to use it. Then we have methods to basically solve or address the issue that when you increase the demand for biomass, some of that might be constrained, because it cannot be possible to increase the production of some of that, or some suppliers are going to respond more than others. And here we have methods for calculating what we call a marginal mix or unconstrained mix of suppliers according to established theories from consequential LCA. And you can find all the examples and calculators. Then we have then we have also methods to actually share data that we use within the project, that we encourage also people to use. These are also based on open source and open access existing frameworks that are well established. So you can structure your inventory data in a specific way, and then you can use importers to different types of software. And this allows for what we think is a fair documentation, findable, accessible, interoperable, and reusable. Then we have methods for the foreground life cycle inventory, the dynamic carbon. I have already been talking about this. That's exactly the same I showed before. Then we have methods for life cycle impact assessment. So each of these is a separate repository with all this material inside that you can download. So here we have a guide for how to perform a life cycle impact assessment on climate change and biodiversity. In particular, here we have recommendations for how to account for biogenic carbon and how to account for dynamic carbon. So this is not about it's about the impact, not about the accounting of inventory flows. So how to characterize the impact. And we have different tools. If you want to calculate, for example, dynamic characterization factors, you can use this tool here. And also we have a data set with the biodiversity characterization factors taken from the most recent studies, where these were open, but we made them importable in software. And then we have methods for handling uncertainty. Here we have a guide for how to do uncertainty sensitivity analysis in bio-based products and beyond, of course. And we have calculators for for pedigree matrices and tutorials for performing this uncertainty sensitivity in practice. And then finally, we have methods for socioeconomic assessment. Here is about techno-economic assessment and quantification of social indicators. And then we have tools for doing multi-criteria decision analysis, so that if you have impacts on different sustainability dimension, you can use this tool to find a sort of optimum balance between them. Yes. What we are doing now in the project is that we have several case studies. So we are applying all these tools that you've seen on the case studies. Well, not every tool in each case study, but we have a sort of combination. But we are testing all the tools that I just presented in all these case studies, and we have preliminary results now. We will have final results in March 25. And we use that to evaluate real-world improvements within the companies that are in the project, and to evaluate whether these methods actually work and make the life better for the practitioners and get added value in the analysis of the bio-based products. And then, as I mentioned already, we are making further refinement of the methods based on the feedback that we get in this application to the case studies. Here you can see a list of the case studies and the partners involved. I'm not going to go into details into that. You'll get the slides, but you see that we have the 5 sectors. We have a company for each sector and an academic institution working together, at least 2 of them. And then we have different case studies for each company. Yes, to conclude, our methods are open here at the link that I showed before already. If you're using those in beta version, we will be happy to hear from you, and you can use this. There is a survey in the repository itself and also here that you can give us a feedback, and this will help us also improving further these methods. And yeah, thank you for your time, and I was presenting here on behalf of the entire consortium. Thank you.
Thank you, Massimo. Thank you very much for your presentation. I don't know if there is any questions in the chat. No, there is not. I have just some questions regarding your presentation, mainly regarding the methods you developed. For these methods, did you also work on the generic data sets in order to be able to analyze it regarding the methods you use? Did you need to develop any other flows in this, for example, eco-event data that you use to do the assessments, or only the methodology itself was enough to how can I say, to do the biodiversity, for example? Did you had to develop any other flows or method flows in this generic data? I don't know if your mic is. Can you open this mic again? Yeah.
Can you hear me now?
Yes, now.
Yeah,
yes.
okay, sorry. Yeah, thank you for your question. But I don't have a univocal answer for all our methods. So in some cases, we found new data, and then to complement the existing tools with new data. For example, this is for the case I presented for the forest model, where we have to find new data to extend the model. In other cases, it was not necessary to find new data, but we had to, for example, take existing data and change the format so that they can be used more easily. So it is variable depending on the type of method we talk about. Yeah,
and you talk about also for the some parts of the presentation. You talk about the space-dependent carbon linked to the softwares. How does it work actually? Could you implement the method in the software, or you use the data coming from the software to do your analysis later on?
No, it's the other way around. So you can use a model, and you get an inventory of a plantation, and then you know how much carbon, if you need a certain amount of wood, for example, of a specific kind, tropical wood, then you know exactly how much carbon is in that, how much carbon has been will be uptaken when you plant a new tree, at what time, and specific time horizon, and using a certain management practice. So you get an inventory of all these flows, like classic life cycle inventory. Per 1 kilo wood, what is the carbon input and output, and the other inputs. And then this inventory that you get from the tool, which is an Excel file, you can import in different softwares. So we have an importer as well. This to give an example, and similar approaches for the others.
Okay, perfect. Thank you.
Thank you for your time.
So if there is any other questions, maybe you can give floor to Lucia to present LCA for Bio. Lucia?
Thank you, Carolina.
Welcome, Lucia. Can you try to share? Yes.
So, hi everyone. I'm Lucia Garcia. I'm member of the sustainability team of Contactica and technical coordinator of LCA for Bio. That stands for Harmonized Life Cycle Assessment Methods for Sustainable and Circular Bio-Based Systems. Before we get started with the methodology being developed in LCA for Bio, I would like to introduce the project and the consortium. LCA for Bio belongs to Cluster 6 under the topic Environmental Sustainability and Circularity Criteria for Industrial Bio-Based Systems. It started on January this year and it has a duration of 3 years with a budget of nearly 3.5 million euros. We are a consortium of 10 members, 2 universities, Aalborg University and NTNU, 3 research centers, LIST, INSA and CESE4, 2 small and medium-sized enterprises, Contactica and Go Up, 1 certification scheme, which is PFC, 1 industry, Sonai Arauco, and 1 industrial cluster, B4C. So the main objective of the project is to develop and validate a new set of assessment methodologies to evaluate environmental impacts and circularity in bio-based systems that can be applied in certification schemes, enabling the trade-off of this type of products and also the development of new prospective life cycle assessment methodologies. Now that we cover the overall picture, and as it started a few months ago, we don't have any outcome to communicate yet, but I will walk you through our key objectives, breaking down not only what we aim to achieve, but also the specific methodologies we use to get there. And in this way, you will see how each objective aligns with our approach and how we ensure effective results. So let's start with the first objective. Improve methodology for environmental sustainability and circularity assessment of bio-based systems. In this case, we break down into 3 steps. First, we are developing a harmonized approach for dynamic carbon footprint, consisting of an improved dynamic inventory assessment of greenhouse gases and coupled dynamic LCA of these flows. We also focus on the improvement of circularity assessment methodology for bio-based systems, identifying circular strategies from the technical circles and cascading. And then we carry out a synthesis and review of the available frameworks and indicators for the relevant impact categories in life cycle assessment to harmonize life cycle impact assessment methods for bio-based industries. And to improve prospective LCA methodologies to assess low TRL bio-based systems, we first carry out a review of prospective LCA approaches to harmonize methods for foreground and background modeling. We develop a framework to generate LCI of upscale bio-based technologies for prospective LCA, harmonize different techniques used for technology upscaling, and tailor them to the case of bio-based systems, coupling with integrated assessment models to consider future scenarios in background inventory data. Building on uncertainty, LCA for Bio provides practical framework for defining and accounting for uncertainty in prospective assessment of bio-based technologies. To understand the potential socioeconomic trade-offs, synergies, and substitution effects, we first define and analyze the methodologies for substitution effects of bio-based systems, intended as to what extent and on which basis bio-based and fossil-based are comparable and substitutable, and if they provide equal functionality. We especially focus on the socioeconomic trade-offs, developing new tools to assess the social and economic dimensions based on key social objectives such as job creation and economic feasibility, including externalities, and integrate them in the LCA framework. To test and validate the methodologies developed in the project, we first identify the high TRL best available technologies to be used as benchmarks. For prospective LCA methodology application and validation, we apply prospective LCA methodology in low TRL case studies. And in this context, we provide guidelines to perform LCA of bio-based systems at both high and low TRL technologies. To develop and test the LCA methodologies to apply in certification schemes, LCA for Bio involves different types of stakeholders to be part of the process. First, testing these user-friendly tools to perform LCA of bio-based products through co-creation workshops, and also webinars to define the LCA standards to incorporate it in existing certification schemes. The last objective is to design and execute dissemination, communication, and exploitation strategies to maximize the impact of these projects and its results, assess the exploitation potential of the technology, and find candidates interested in using the tools, and also organizing clustering activities and cooperation with other projects, EU platforms, institutions, and regulatory bodies, seeking collaboration, cooperation, knowledge spread, and synergies. And I'd like to thank you everyone for your time. I hope you found the information valuable. And if you have any follow-up questions or would like more details, please feel free to raise them afterwards, or you can find here our contact details to reach us by email. Thank you.
Thank you very much, Lucia. I don't think there is any questions in the chat. I'll just ask you regarding the timeline, because as the project is started at the beginning of 2024, when are you expecting to have some maybe some deliverables on these methodologies that you are working on?
So at the moment, we just publish deliverables related to the reviews we are carrying out. And for next June, we will start with the first deliverables of the methodologies, especially for the dynamic and carbon footprint. Yeah.
Okay, thank you. Perfect. So we have to keep in touch to see these methodologies appearing, and we'll try to integrate as much as possible all the methodologies that have been presented today in our project. That is the main objectives of the webinar, is also to present the methodologies for the other maybe other projects that want to implement new methodologies related to bio-based systems in the LCA. So is there any other questions, remarks? I don't see anything. So if there isn't anything else, I really want to thank you, Eduardo, Massimo, and you, Lucia, and also Margarida, that's here close to me, presenting the methodologies developed during all these European projects, Calimero, Aligned, and LCA for Bio. I'm very happy to have you here and all the participants, and hope we can keep in touch and see all the advancements in all these amazing projects. Thank you all, and have a nice afternoon. Bye-bye.
Thank you.
Thank you. Bye.